What about this question? What if you are asked to write a quadratic equation whose solutions came from the set of irrationals? So, if you got ax squared plus bx plus c equals 0, it might be easy to ditch this guy. So your irrationals, these are your square roots. So what if you had this? I mean, the easiest one ever is just going to be x squared equals 7. That's it. That's a quadratic equation, and the solutions are going to be from the set of irrationals, because if I undo it, I do the square root of this, I do the square root of this. So my solutions are going to be x equals plus or minus square root of 7. Done. Okay, now write a quadratic equation whose solutions are imaginary. I could do the same thing. I'm gonna definitely ditch this guy, the bx. And I'm just gonna go x squared equals a minus 7. So what number times itself is gonna give you a minus 7? Undo the square, undo the square. X equals plus or minus square root of a negative 7. So it's going to be plus or minus square root of a negative 1 times square root of 7, plus or minus I times the square root of 7. That's imaginary. 12, see 11. Okay, find two numbers that multiply and give you negative 35, add and give you negative 10. This is a sweet question. So they got to times together and give you a negative 35. They've got to add together and give you negative 10. So let's work totally backwards. It should look like this. X squared. They got to add and give you minus 10, minus 10x. They got to times and give you a minus 35 equals 0. Okay, you can't think of any because the only factors of 35 are 1 and 35 and 5 and 7, and you can't get a minus 10 out of either of those, so you know it's not going to come from the integers. It's going to come from probably the irrationals. So you're going to use one of your skills. You're going to use completing the square. You're going to take this minus 35 and get rid of it. Plus 35 plus 35. So it's going to be x squared minus 10x equals 35. And you're going to add your own number of choice. So the number you're going to choose is going to be b divided by 2 squared. So it's going to be a negative 10 divided by 2. It's negative 5 times itself. Negative 5 times negative 5 is going to be 25. 25 is your number. Okay, now you just created a perfect square. This is pretty clever. So you're going to factor this. It's going to be x minus 5 times x minus 5. But let's just write x minus 5 squared. On the other side, 35 and 55, or 35 and 25 is 60. Okay, now undo your square. Square root the left, square root the right. So you got x minus 5 equals plus or minus square root of 60. Okay, 60. Is there something we can pull out of 60? So 60 is a 10 and a 6, a 5 and a 2, a 2 and a 3. So the square root of 60 is 2 squared times 5 times 3. So there's not enough 5s, there's not enough 3s, but there is enough 2s. So you're going to swap out 60. X minus 5 equals plus or minus 2 times the square root of 15. And then just add 5, add 5. Your answer is going to be 5 plus or minus 2 times the square root of 15. Okay, but now here's where the logic kicks in, and you really got to stop and think. Because, let me show you with one that's easy to see. Okay, I'm going to erase all. Let's just erase this much. Okay. So if you've got this, if you've got an easy guy, let me change colors. If you've got x squared minus 7x plus 10 equals 0, what goes in the template is your 10 and your minus 7. What is going to times and give you 10, add and give you minus 7? Well, it's going to be a negative 5 and a negative 2. So it's going to look like this: x minus 5 and x minus 2 equals 0. But your actual solutions are x equals 5 or 2. So your solutions, that's where I'm at right now. I got my solutions. But I am about to plug something into my template. What am I going to plug into my template? Because the question is, what two numbers times give you negative 35 but add and give you negative 10? You do not plug the solutions into your template. You plug their opposites into the template. So I'm going to plug in a negative 5 plus 2 times the square root of 15 and a negative 5 minus 2 times the square root of 15. So you can do the addition real quick, and if the addition checks, what's the negative 5 plus 2 square roots of 15 minus 5 minus 2 square roots of 15? That's a negative 10. And your multiplication is going to check also. So your multiplication is going to be negative 5 plus 2 square roots of 15, negative 5 minus 2 square roots of 15. So it's going to be 25 plus 10 square roots of 15 minus 10 square roots of 15. So that cancels, thank goodness. And this is going to be minus 4 times 15. 4 times 15, that's going to be a minus 60, and a minus 60 plus 25, there is your minus 35. Sweet, you found them. Okay, imaginaries. Imaginaries, if you add them, it's a piece of cake, just like terms. Negative 3 and 18 is going to be 15, a 5i and a minus 7i is minus 2i. Multiplication, you just got to remember this. I is equal to the square root of a negative 1, but I squared is equal to a negative 1. So let's times them. 3i times minus 2i is going to be minus 6i squared, minus 6 times a negative 1, so that's going to be a positive 6. Anytime you come across an I squared, swap it out for a negative 1. 6 times 5i, 30i. Just FOIL, distribute. 7 times 2 is 14, 7 times minus 3i, negative 21i, negative 6i times 2 is negative 12i, negative 6i times negative 3i is going to be positive 18i squared. I'm going to swap out an I squared, it's going to be 18 times a negative 1, so it's really going to be a negative 18. I'm going to combine that with my 14, that's going to be a negative 4. Add these two guys, negative 21i, negative 12i, negative 33i. That's your answer. Okay, I'm going to leave this one. We've done that. Just undo it, solve for x. This guy, though, you cannot have an imaginary on the bottom, so you're going to multiply it by 1. You're going to multiply it by the complex conjugate. It's going to be 4 minus 2i. You got to times the top by 4 minus 2i. So, got to times each of these by 3i. So it's going to be 12i minus 6i squared, 12i plus 6, that's the top, the bottom. Since I know that the middles are going to cancel, all I'm going to do is times first and first, that's 16, last and last. Minus 2i times 2i is a minus 4i squared, I squared is a negative 1, negative 4 times a negative 1 is a plus 4, 16 plus 4 is 20. So on top I got 12i plus 6. On bottom I got 20. Simplify the fraction. Divided by the GCF. They all can be divided by just 2. So it's going to be 6i plus 3 divided by 10. Done. I to the 52. If you've got I times I times I times I 52 times, where are you going to end up? Remember, every fourth I is positive. But if you think in terms of this, think in terms of I squared. How many I squareds are there in 52? There's gonna be, I know there's 50 is pretty easy. 50 cut in half is 25. 52 cut in half has got to be 26. So in 52 there is exactly 26 2's. So this is legal. I can rewrite I to the 52nd as I squared to the 26th. And I'm going to swap out I squared for a -1, and I know a -1 times itself 26 times is going to be a +1. Okay, I to the 64th. Oh, I should have done one of these odd and one of them even. So let's do this. Let's make this guy odd. So let's swap out a 64 for a 63. Alright, I to the 63. Same concept. How many I squareds are there in 63? There's going to be 31 of them. 31 squares takes me to 62, but there's really 63 of them, so I need to add my own at the end. Okay, now I squared, so it's going to be I times a -1 31 times. A -1 31 times is going to be a -1, and a -1 times I is going to be a -I. Quadratic equations, practice. So we got 4 different types. And I think that's it. So 4 different types. You choose whatever you want. Zero product property, completing the square, quadratic equation. This guy kind of looks intimidating. If I go 6x squared plus 8 plus 22 equals 0. Oh, you know what? I noticed there's no x. So when your ax squared plus bx plus c is 0, this guy's missing. So if that guy's missing, it's actually going to be a piece of cake. So I'm just going to undo it. I'm going to maybe get the 8 over there. I'm just going to solve for x. I'm going to undo the plus 8. I'm going to minus 8, minus 8. So I got 6x squared equals a minus 30. Divide by 6, divide by 6, x squared is a minus 5. Undo the square root. So I've got x equals plus or minus I times the square root of 5. Okay, that wasn't too bad at all. This guy, kind of like the other one at first, this one kind of intimidates me. So I'm going to go 12x squared minus 4x plus 9 equals 0. This one, definitely the quadratic formula. So A is 12, B is -4, C is 9. Quadratic formula, because this, I mean, they got nothing in common. 12, 4, and 9, I can't divide them by anything. And 12 is what intimidates me. That's kind of a ugly number to start with. So x equals -b plus or minus the square root of b squared, 16 minus 4 times a times c all over 2a all over 24. So 16 minus 4 times 12 times 9. Ugh, it's kind of ugly. We got 4 plus or minus the square root of a -416 all divided by 24. Okay, 416, there's got to be something that comes out of 416. 416, if I break it up, 416 divided by what? Divided by 16. Sweet, 16 and 26. And I don't think anything's going to come out of 26. So check this out. I'm going to go square root of 16 times square root of 26. Square root of 16 is going to be 4 times the square root of 26. So, but it's negative, so I know it's imaginary. I'm going to go 4 plus or minus 4i times the square root of 26 all over 24. 4, 4, and 24 can be all divided by 4. So 1 plus or minus I times the square root of 26 divided by 6. Alright. These next two, they don't look as scary because they both start with 1s. So minus 3, x squared minus 2x minus 2 equals 0. So does there exist something that's going to times give you negative 2, add give you negative 2? No. So complete the square. Kick that back over, plus 2 plus 2. You got x squared minus 2x equals 2. Okay, I'm going to add my own number. So I'm going to do this, b divided by 2 squared. So look at your b, your middle number, negative 2, cut it in half, is negative 1, times negative 1. The number I'm after is 1. So it's going to be x minus 1 squared equals 3. Do your square root. And here's what you got. X minus 1 equals plus or minus square root of 3. Plus 1, x equals 1 plus or minus square root of 3. Not too bad. Last one. M squared minus 3m minus 40 equals 0. Does there exist two numbers times give you minus 40, add and give you minus 3? Yes, it's going to be 8 and 5. 8's negative. So this one's cakewalk. M minus 8, m plus 5, answer is 0. So m has to be either 8 or a minus 5. Okay. Let's call it a day. That's it. Quadratic formula. Be familiar with how it was brought to life. The quadratic formula evolved from what? It evolved from completing the square. So completing the square used to be the only test they had to figure them out, but then they did it enough, they found a pattern, and that's the mother of this quadratic formula. So we only used to go to right there, but then the mathematicians figured out, you know what, let's keep going. Then they came up with this, and now this makes it easy to find any answer, no matter how ugly the solutions are.